until 2028,
Ah.
unless any of them develop a new kind of model or new mathematics or new algorithm to be able to train the AI agent.
Mm.
However, I think the question now is more about there has been so many investments being made to AI. The question is how are the business going to make enough money to continue? So certainly we are in the phase that everyone puts into investment in resources and try to do everything else. The question will be until when we will see that it lands in general users. So it doesn't land only to the programmers who are actually now the major group buying the services. So the major group or the major customer for AI industry currently are not everyone. It's not you, it's not me. It's the being fired and losing jobs, the program engineers. So they are actually the first customer and the first victims being replaced. So how this will go on, I don't think we could have a certain conclusion or summary until today or even 2028. But hopefully until 2028, we could start to see a clear path, like how this is going to go. On the other hand, this industry costs so much. So semiconductor industry costs so much to build the fab, to build the landscape of industry, to build the landscape of all these factories and etc., and even just the infrastructure. So imagine the energy costs and it together with the data center. So now we started to see like invest into nuclear, small modular nuclear reactors, and etc. and etc. So this kind of development completely turn our head around in regards of what is the energy consumption, what is the water consumption, and how do we react in such a scale. I would say compared to the 70s, compared to before the World War II, the scale of energy and water costs consumption is completely different. And I had some statistics here, so I was looking at, this is not the data center. Data center is in a worse figure. You could just easily Google or ask ChatGPT. So what I put here is just the fabs, the factories, building and producing, manufacturing the hardwares. So it's not even the data centers themselves. So only making the hardwares would already cost this much. And if we consider, if we still believe that we want to do it in a sustainable way using renewable energies, it will be even much more challenged ever than before. So the challenge is currently, I hope you already bought all your phone and PCs and everything, because you could see that the memory price is not going to come down until, I would say, 2028 for sure. And all the resources and all the business capitals are driven by AI, so it kind of excluded everyone else. So the other things will need to be made way by being squeezed or overflow the demands of the AI. And we also have a talent shortage, of course. So while the industry boom up like 14%, I don't think we ever be able to catch up with enough talents. On the other hand, we have all these people losing jobs because of AI replacing them. However, we're looking at a very imbalanced figure. So the people being being replaced are not the one who are needed. So I think this is something you people in research, in academia, in education, and we people in business, in industries, we will have to come up with some good execution plans that could solve the problem. Yes. So in the later presentation today, I will show you. I have actually already explained a bit about why we are here and what we do. So in every slide, I will kind of like to go through all these things. The major messages here is about who we are, Nordic chip ecosystem in a region, and what is our strengths and what is our position in the global landscape. So Nordic chip collaboration actually is organized by the industry needs. So our goal is to create a common value proposition across the Nordic region. And as I mentioned before, we work together without too much strong internal competition. So we could unify our strengths to put a good value proposition, to position the Nordic as a region with a certain strength in Europe. That's the number one goal. And then the second goal is, of course, globally. And the reason we have already gone through in the previous is that we have such a boom in the industry needs. We also have anxiety from geopolitics. We have energy anxiety as well in sustainability, in whatever you started to see. And also what we mentioned is that it's a very costly industry. So we have to also have a joint resources in capital even to be able to support the industry to grow. So with all these purposes, we have been around since late 2024 and we have delivered. The first purpose is to bring all the Nordic industries together. So we organize a meetup. So the first year we met in Finland, and the second year we met in Sweden, and the third year, which is this year, we're going to meet in Trondheim in Norway. So the reason of circulating around is that we try to bring also from the local strengths together, so you do know who are the people around you in the industry and who you can talk to and who you can collaborate and work with. We also bring the joint forces, as I said, in the funding agencies, in the funding partners, even in the investment and the venture capitals. So the investors and venture capitals are important because without having enough capital, we are not able to support the innovation. It's important to have the innovation for us, especially in the Nordic country, because we don't have manufacturing capacity similar to Taiwan, less, and even not to say that the capacity in Eastern Europe or in Germany or France. So that is a completely different scale. Therefore, for the Nordic innovation startups, the capital resources is super important. And I give you also an overview regarding Nordic innovation. So Nordic innovation is an official joint force in between the Nordic countries. So the purpose is to create a wealth for the Nordic region together and have socially sustainable region together to keep or strengthen the competitiveness in the Nordic region. Because we understand that if we're alone, we're small, but if we're all together, we're actually stronger. So that is the background and also the purpose. Here I started to show how does the Nordic chip value chain ecosystem look like. So overall in the Nordic region, we have more than 300 plus companies. in the industry. And however, over 90% of all the companies are SMEs, which means small, medium-sized companies. And this is the EU criteria, which means if the company is less than, if the companies have less than 250 employees, then you classify it as a small, medium-sized enterprise. And the turnover yearly is less than I think it's 500 million, no, sorry, 50 million euros, then you classify it as SMEs. So you can see that compared to the power strong countries like Taiwan, Japan, or US, and etc., the Nordic region is still small. But even so, you can see that compared to the general industry, the Nordic chip type of companies have stronger growth. So, which means the Nordic chip, or the companies, the semiconductor companies in Nordic region having similar growth as the rest of the world, which means this is significantly higher than the average industry level in the Nordics or in Europe. So, and also on the other way, important here is the ownership. Compared to the other European countries, the Nordic region's companies are much more international. So this is the spread of how these companies are owned. So you can see around 1/3 of the semiconductor companies in Nordic are foreign owned, and they were owned by some kind of like a good spread. Or many like majorly are still like the European owned, but we also have the other countries owning the companies in Nordic. This is the ecosystem map in the three countries. One may ask, why don't we have Denmark? Denmark did not join from the beginning. They will join from January next year. So finally they are coming. So currently we have Finland, Sweden, and Norway. And Iceland is rather small, so they did not have enough resource and then industry to join this. We can look at the map. In Finland is much more spread geographically with their different strengths at the different locals. And in Sweden is majorly two sides. So here is around Stockholm in the east side, and the other way is at the west side, which is Gothenburg and Lund area. In Norway, it was also rather clustered. We have two sides nearby Oslo, and we have one site which is near about Trondheim. That's where we're going to meet this year. So you are very welcome to have the presentation if you feel like to. So if you're interested to see like who are there and what are the strengths of each different locals, this is a very good map. And this is the spread of different companies operating in the Nordic. So obviously some of them are international. For instance, you see ARM, you can see Bosch is from Germany, you can see MediaTek from Taiwan, we have NVIDIA in Denmark, and etc. So some of them are like very international, and we also have the local players. For instance, Silex. Silex is the largest MEMS foundry. We also have a few good equipment providers. So I would say the strengths of the Nordic regions are more niche application, and historically we work very closely with the European vertical players like Bosch, like ST Microelectronics, and as NSP, and etc. So this is how it works like. And the strengths overall in Nordic, as I mentioned before, Nordic doesn't have a capacity in manufacturing in general. The only capacity of manufacturing we have is actually our MEMS. So MEMS are mechanical, electrical, signal powered IC. I could give you an example is if you take your phone, we have a camera in the phone. So while you're talking, your voice creates vibrations, right? So these vibrations, they vibrate air. The air is like a flow, or your voice coming to us like a sound power into the microphone. So the microphone in your phone is one of the MEMS. So yeah, so that's the example. So the MEMS is that it's a little vibration, like vibrating, you could call it needle. It looks like a needle, and your voice would create some kind of wave, and the energy that absorbs or vibrates in the needle, and this needle is catching your voice and then turn this voice into electrical current. So MEMS are the IC turning either sounds or light into electrical signal, and it transmits these signals back into the integrated IC, pack it into the chip in general, and then process that. So you could say MEMS is important in application perspective, because every day we need to measure sound, we need to measure light, we need to measure temperature, we need to measure many things. So MEMS are, you could see that as a sensor system which could catch all these nature signals and transfer that, convert that into electrical current signal, and then send back to the main IC process. So that is where one of the strengths of the Nordic, and that is also the only volume capacity the Nordic country has in manufacturing ICs. So to be able actually to reach here, IC design, IP design is also the top strength of the Nordic ecosystem. So the major players where you can see here, those ones, Nordic Semiconductors from Norway and Sivers also from Sweden, these are fabless. So these design companies don't have manufacturing capacity. They are fabless. They design the chips and they design their applications and send it over to the manufacturing guys, send it to the companies. And as in MEMS, we do have Silex and we do have a Manscape, who are manufacturers of these kind of MEMS ICs. And regarding in the other type of, for instance, MCUs for microcontrol and analog chips, and those are, we have a VTT in Finland and as well NTNU in Norway. So they develop as well their own research, and they actually make these specific ICs, and these specific chips are more dedicated into, for instance, radio waves, for instance, into military defense. So these are very specialized. And in Norway and Sweden, these are also go into the space, because you need to have very radio resistant ICs. So these are not big volumes, but they are very specific. And as well, they go to, for instance, the defense company in Sweden is Saab. So Saab makes its own missiles, makes its own defense system, makes its own fighter jets. So they develop these kind of specific ICs for the defense equipment, etc. And in Norway, it's Kongsberg. They are specialized earlier years in defense system and also in maritime. I hope you watched the football game in the World Cup, so you all learn how the Norwegian rolls. So Kongsberg is one of the largest provider in marine kind of leading ahead, like leading advanced control system. So that's their major. So what you could see in the Nordic, and so like in photonics, I would say it's more carried by the Finnish and also the Danish, because they use photonics in not only in telecom, they also use photonics in many other, for instance, life science, in the detection, or generate different lasers, generate different light sources, and etc. So you could see, and the next one is actually quantum. Yes, you do also have the photonics that work into quantum.
You have 2-3 minutes to finish.
Oh, okay, good. So overall, this is the strength of the Nordic ecosystem, and I would say they are more application focused rather than supplying the overall supply chain. So yeah, and here it's just more about the breakdown. I have already said similar things, so this is just to categorize that to be able to see the advantages by countries. So this is us, and here we just specify how we are looking good together as a Nordic region. And here is us. We have our own website, and I am this one from Little Sweden. And our report you could find on our website, and if you're interested to see more details in the report. And you are also very welcome to join us whenever we have a webinar, or even sometimes in a physical meetup. Yes?
True. Okay,
Great.
so audience, we have only 3-4 minutes. If anyone wants to question from Dr. Feng Tai, you can ask, and then we can conclude. If anyone is from engineering background, he or she will be more interesting.
Of course, I will be happy to.
Okay, so no question. Okay, I have a question. So
Yeah, sure.
it's the basically your company is working on the semiconductor development, right? So
No, I work with the agency.
with
So
with the agency.
yeah, I'm the trade and invest agency. Yeah.
So basically itself your company or your agency is not for the manufacturing. It's related to the companies who manufacture.
No, our role is to using the coordinated state resource to support the companies.
Oh, so you provide the resources basically to start
Yeah,
up.
to meet what they need to develop. Let's
Ah,
say if they want to go to the US,
yeah.
I would actually connect them to my colleague in the US. And
Ah,
whatever they need, for instance, if they need to find supplier, they need to find customer, they want to establish, or they want to find investors in the US, we do that.
okay.
Yes.
Great. So, do you think in the future anything it will be helpful for biomedical or biology?
It will. Like I said, MEMS, for instance, specifically explain about MEMS is
Yes.
because it has a great potential in biomedical or life science application. Because it could catch different temperature, color, voice, sounds, like all these signals that you need to receive. And even sometimes, if you want to measure how you stimulate DNAs or cells. You could measure through that kind of devices. So if some of you may be working with a biochip, that is the thing.
Great.
Yes.
Okay.
Yeah.
So really amazing talk, and I think everyone did join it for Nordic chip ecosystem, and especially
I hope so.
for me
Yeah.
it was also very a new knowledge, and I
Mhm.
really, because at the semiconductor I know generally, but because it's now in everywhere in our devices for
Yeah.
everything, but
Yeah.
it's really like for the people like you who are connecting and who are helping actually for the new ventures. It's really an amazing, and it's not only for the like the countries who already have this power, but also for the country that are poor in this area, and they can get more knowledge and more resources.
That's very good. Yeah, and I do believe that there's nothing is useless.
True.
So whenever you can create, you just need to know.
Yeah, exactly.
Yeah.
Yeah,
You just want to see potential. Yeah.
yeah,
I'm happy to have this contribution.
exactly. Okay,
Yeah.
Dr.